Welcome back, learners. So now, as we have said before the ad break, we're moving on to our next concept, that being the reflection of light. So you're going to be now looking at the reflection of light in detail. So with that, these are the things that we need to know. That when light hits a surface, it is often reflected off a surface. So that means it often bounces off the surface. So remember that the reflection, that's now the bouncing back of light coming from the source, or coming rather from a luminous object onto the surface, and if it bounces off that surface, it is said to be reflected. So most surfaces reflect light, and then when light strikes a reflective surface, it can change direction, as we can see from the picture. When the light coming from the source, being the candle in this case, the luminous object, because this is giving off light. So when the light was coming off from this particular luminous object, it was going in a certain direction, and then when it strikes the surface, it changed direction, as we can see, as we are saying here. Most surfaces reflect light, and then when light strikes a reflective surface, it can change direction. The direction of this light ray did change. Right. When light reflects off a surface, the ray which hits the surface is called an incident ray, or the incident ray. So the light, or the light ray that is striking the surface, that is going towards the surface, that is called the incident ray. Now the ray of light which is reflected from the surface, the one that bounces off the surface now, that one is called your reflected ray. So the ray coming from the source going towards the surface, in this case being the mirror, this is called your incident ray. Now the one that is going to bounce off the surface going to the observer, in this case being the eye, that is going to be called your reflected ray. Reflected and the incident ray. So looking at that in detail then, what do we have then? So with those two light rays that we have said, we can draw something called a ray diagram. So when we draw diagrams of reflection, those diagrams, we call them our ray diagrams. We also draw an imaginary line which helps us measure the different angles. So we have two angles that you're going to be talking about when drawing a ray diagram. We have the angle of incidence and the angle of reflection. So the line that you're talking about, this line that is going to be helping us to measure the different angles, is called the normal. So we now have talked about three lines. We talked about the incident ray, which is the ray coming from the source. We talked about the reflected ray, the one that is bouncing off the surface onto the observer. And then now this imaginary line that helps us to measure the two angles that are there in that particular ray diagram. And that line is called the normal. So the normal line is always drawn perpendicular to the surface. So the normal line is always drawn perpendicular to the surface. And then between the normal line and the incident and also the reflected rays, we have two angles, as we have said. So between the normal and the incident ray, and between the normal and the reflected ray, we have the two angles. Those angles are, number one, we have the angle of incidence. That's now the angle between the incident ray and the normal line. We also have the angle of reflection. That's now the angle between the reflected ray and the normal line. So now we have five things: incident ray, reflected ray, the normal line, the angle of incidence, and the angle of reflection. So five things that you always need to have in our ray diagram of reflection. So this is basically what you've been talking about here, our ray diagram. So a ray diagram is a drawing that shows the path of light. So light rays are drawn using straight lines and arrowheads. So the arrowheads are showing the direction of the light. So because light travels in a straight line, the diagrams below shows examples of a ray diagram of reflection. So the light coming, or the ray coming from the source, is called the incident ray. If our source was to be somewhere up there, this is going to be our incident ray, and this is shown by the arrowhead, the direction given by the arrowhead. This is our incident ray coming into the surface and then bounces off the surface. Now, if it bounces off the surface, it now becomes our reflected ray, as shown by the direction of the arrowhead. Now, the imaginary line that you talked about, the normal line, it is drawn perpendicular to the surface, meaning that there's going to be an angle of 90 degrees between the surface and that particular line being the normal. Now, this normal line helps us to measure two things. Number one, our angle of incidence, and number two, our angle of reflection. We did say that we find our angle of incidence between the normal line and the incident ray. So basically, this is going to be our angle of incidence. So we can just use small letter I to show that we're talking about our angle of incidence. Now, this line also helps us to measure the other angle on the other side now between the normal and the reflected ray. And this is going to be known as our angle of reflection, using R to denote that we're talking about our angle of reflection. In this case, we're noticing that the two angles are equal. The two angles are always going to be equal when talking about the reflection or the ray diagram of reflection. So in more detail, this is what we have now as a different picture that shows the very same concept or the very same ray diagram. Now, our incident ray coming from the source given by the direction strikes the surface and then is going to be reflected off the surface given by the direction. So this is going to be our incident ray, that's going to be our reflected ray. Then the line drawn perpendicular to the surface, meaning that there's a 90 degrees angle there. So the line drawn perpendicular to the surface, we said that line is called our normal line. So the normal line helps us to measure the two angles. Because there's an angle between the normal and the incident ray, this angle here is called our angle of incident, or denoted by I. And the one between now, again, the normal and the reflected ray, that's going to be given by small letter r to show that this is our angle of reflection. Remember, we said that those two angles are always going to be equal. So the angle of incidence is equal to the angle of reflection. So this is what we always need to keep in mind, that these two angles that we can measure by or through the help of the normal line, those two angles are always going to be equal. Right. So now, what then happens if light is going to strike now a surface that is not so smooth? So what happens? So what happens when we do not have a smooth surface? We did say that when light strikes a smooth surface, it is going to be reflected off the surface. But then now what happens if the surface is not smooth? So reflections of rippled water are not clear. So we are able to see our reflection of a mirror because the mirror is a smooth surface. Light can be able to be reflected off that particular surface. Then we can be able to see the image. However, if the mirror was not smooth, how were we then going to be able to see the image from that mirror that is not smooth? So reflections, as we have said, of rippled water are not clear, but rather they are blurred. Why are they blurred? This is because the light rays have not reflected parallel to each other as they do from a smooth surface. So in a smooth surface, those light rays coming from the source, the incident rays, are going to be reflected parallel to each other. However, should the surface be not smooth, then the light rays are not going to be reflected parallel to each other. However, they are going to be scattered in different directions. And because of that, that is not going to give us a clear picture of whatever that we are looking at through a reflective surface. So as we can see, on a smooth surface, the incident rays are going to be reflected off that particular surface parallel to each other. So they're always going to be reflected off that particular surface parallel to each other. However, in a rough surface, the reflected rays, as we can see, they are scattered all over the place. So this particular diagram here, or this particular scenario, doesn't give us a clear picture. We can even see from the picture here that the water is rippled. So because of that, when we're looking at the image that is formed on the surface of the water, the image, it is not clear. It is not a smooth, clear surface, because, it's not a smooth, clear image because of the light rays that were scattered all around that particular space, because the surface, it is not smooth. So this table now shows the differences between a smooth surface and a rough surface. We're saying that straight parallel rays are approaching in two different surfaces, the one on a smooth and the other one on a rough surface. And because of this, these ones are going to be reflected parallel to each other, and they're going to give a clear or a specular image, whereas these ones are going to be reflected in different directions, are going to be scattered in all over this place. So therefore the image formed on this particular picture, it is not going to be, or on this particular diagram here, it is not going to be a clear picture. And because of that, the picture that is formed from a not so smooth surface, it is going to be blurred. So these diagrams here, they're basically reiterating what we have said about the smooth surface and a rough surface. The smooth water gives us a clear image of this mountain. However, this rippled water, it's a wavy water, it doesn't give us a clear picture of this particular mountain here. And why is that happening? Because the light rays coming from the source are going to be scattered all around the place and not giving us a clear picture that we may want to see. So now we have talked about how we are able to see light, how we are able to see color, because color, it is coming in white light, and then the colors are going to be reflected. Some are going to be absorbed. The ones that are reflected, those are the ones that enable us to see the color of the object that we're looking at. We've also talked about the reflection of light, that light bouncing off a smooth surface gives a clear picture, but light bouncing off a rough surface or a wavy surface, as we can see here, doesn't give us a clear picture of whatever object that we are trying to look at. So I hope you had as much fun as I did. Until I see you next time. Bye.